I'm Pavel Odintsov. I'm from FastNetMon project. I'm software engineer with great passion in network security. And on this presentation, I will talk about quite a specific case and type of DDoS attacks, which is actually DDoS attacks coming from internet exchange points. And in this presentation, I will focus on perspective of customer of internet exchange point, not internet exchange points itself, because it's quite different. So, because we are going to talk about DDoS attacks, first of all, I would like to make very clear what kind of DDoS we are talking about, because there are many types of DDoS attacks exist on this planet. And in this presentation, I will talk exactly about network DDoS. But still, network DDoS, it's quite weak explanation. It's unclear what we are going to talk about. Because one of the quite disappointing things about explanation and types of DDoS is that sometimes they name it quite strange way. And you cannot understand what, like, for example, like type of attacks low lowers. What does it mean? Like, even worse, how can I actually defend it? Do I have any options for it? That's the reason why I prefer to be very explicit about like explanation of attack types. So, we are going to classify DDoS attacks in terms of well-known OSI model. So, in this presentation, I will focus on levels 3, levels 4, and of course, both versions of protocol, like obsolete one, IPv4, and IPv6 one. So, in terms of fields, you can see headers of all protocols mentioned on this slide, and literally any field can be used for attack amplification or as attack vector. So if attacker can randomize them or create some special sequences of fields, like they can randomize actually protocol, simple source port, destination port, source IP, and then create many ways how you actually can disrupt network. So, but in like common explanation from presentation from DDoS vendors or network vendors, sometimes most common and most popular attack types will be referenced as TCP floods, UDP amplifications, many types of it, or different kinds of like fragmentation attacks, spoofed attacks. That's how typically people call them. But in terms of like what kind of DDoS we are talking about, it's enough to say like we are talking about L4 and L3. Because everything else is out of scope, because from a network perspective, from like perspective of transit provider of internet exchange points, we literally have no way to see for sure what's happening on level, for example, 7, or on top of it, some on application level, because typically it's encrypted and extremely complex, and network equipment wasn't built to look like deeper than levels 3, 4. Maybe we can find some like tunneling like headers, encapsulation headers, but that's all we have, because network equipment is not built for doing deep inspection. It's very different class of hardware. So, and what is about weather? So, because we're in Manchester, and so weather topic is quite hot, I would say. So, but why I use this like weather? Like it's because we're talking about DDoS. DDoS is technical stuff. Can we say for sure, like next month we will have 10 DDoS attacks? Or something like more predictable, because technical stuff can be predicted. Yes, sure. Unfortunately, it's not. There is some correlation, of course, and back in time, I would say before pandemic, there was like quite clear correlation, like summer was quite quiet time about DDoS attacks, and like autumn was quite hot, and sometimes you can find like some like very like active times, like Black Friday, which can cause spike of DDoS. Because like we can expect more, but pandemic changes everything. For the last 2 years, I cannot say for sure that there's any way to say like something unusual like happened in autumn or summer. It was average. And from just to prove my point, I shared my information about like scale of attacks over time for like mostly summertime from Vexility. And you can see it's about 1 terabit scale attack. It's quite frequent. And problem is that DDoS attacks they're not going to disappear, because sometimes when we are talking about things, some problems may disappear. Like it's not a problem anymore, so we don't need to do this, we don't need to work on it. And DDoS attack is here to stay, unfortunately. So we need to solve it in some way. We need to deal with, because I remember how it was like something like 10 years ago. 10 years ago, it was like sacred knowledge. Like I have a friend, this friend like experienced DDoS attack in first hand. But now I suppose everyone had like kind of experience with DDoS, and all the time it's quite frustrating kind of experience. What is the scale of DDoS? From last presentation, we saw like we have attacks on scale of 1 terabit. And let's look on on IXP load. This one I got pretty like lots of slides, lots of technical information from Moscow Internet Exchange, and it's their average traffic. You can see it's about 4 terabits. Like, should we expect that like even 1 terabit scale attack can be handled by Internet Exchange point easily? Maybe yes, maybe not. How we can prove it? Like, let's look on official marketing information from Moscow Internet Exchange. It's their official numbers. They claim to have a switching capacity of up to 8 terabits. Impressive. So what does it mean? It does mean that they can for sure handle at least 3 or 4 simultaneously running DDoS attacks of terabit scale without any degradation. But again, it's, you know, from 4 terabits on average for 8 terabits, it's not that impressive. So that's why I reached their technical stuff. And like, is it up-to-date number or it's like, you know, safe assumption? Because when you publish something on site, you need to be absolutely sure that this number can be delivered by your equipment. And what we found out after long conversations, those numbers, about 8 terabits, they're quite outdated, I mean 4-year outdated. And they were about like very old platform used by Moscow Internet Exchange back in time. And then we decided to find out how much they can actually do it now. Because, you know, considering like switching capacity of modern platforms, those numbers may be a little bit different. And what we decided to do, we just accumulated like switching performance of every platform used by Moscow Internet Exchange, counted number of ports, calculated how much we can actually push traffic to them, and we calculated it was up to 152 terabits of spare capacity. Of course, we cannot expect that it will be provisioned like automatically. But at some point of time, of course, it may need some extension from customer side. Like plug more ports, maybe extend a backbone a little bit in case of interconnections between chassis. But again, we are talking about 100 terabits of switching capacity. That's enormous. And again, look at 1 terabit attack in scale of 100 terabit of spare capacity for switching. Is it any danger for switching platform? It's not. It's definitely not. We will not see any kind of a degradation. We will not see any kind of performance issues from Internet Exchange points. And then what is the point of this conversation? Why we are here? What is the problem? And problem, so let's try to investigate it a little bit. This one, I made quite short surveys about like 55 responses from different companies. Let's have typical ISP of small, medium-sized looks like. So we have multiple transit providers, at least 2, of course, for redundancy. We have at least 2 Internet Exchange points for different reasons, because, you know, it's, and some private interconnections. And what is the problem with this setup? So one of the things when we are talking about Internet Exchange points, what is the point of Internet Exchange points? I think kind of trends, it's like what is the purpose? Like Internet Exchange is about exchanging traffic. But it's not very equal, because very large number of companies actually use Internet Exchange points to reach very, very loaded and traffic-intensive caches of CDN providers, like video services, CDN services, content companies. And that's why I explicitly put caches of CDN providers behind in IXPs. So, and let's imagine that our company, again, abstract medium-sized ISP, has no ways to actually defend DDoS. No visibility, no mitigation, nothing. What we can do? Let's imagine we experience DDoS attack coming from first IXP. Obvious somebody called us in the middle of the night, we have degradation, then we can check diagrams, like, okay, we have great spike of traffic coming from internet exchange points. What we can do? But at this point of time, we don't know what is the target, because there are no simple way to find out what is the target of attack, because you can be in charge of like thousands of like millions of IP addresses, and which one is actual target, or which prefix, you don't know, unfortunately. What you can do, you can cut it. Simple, depeer it, like plug, remove a socket from it, and then problem solve it. Fine. But at what cost? Like again, look, we lost access to cache behind the IXP. What does it mean? Actually, instead of using absolutely reliable and very close to us location of CDN cache, we will move it to transit. And then transit will decide what is the closest one. And in some cases, if you use, like, for example, like tier 1 transit, then it may be somewhere like across the pond or somewhere in Europe. So it will be suboptimal. But still, not a big deal. Customers will complain a little bit, but then they will stop. Let's imagine that attack started going over Internet Exchange 2 and Exchange 3. So all of them. Fine, we can cut all of them, not big deal. Again, we lost connectivity to every single cache. Again, customers may reach them like over transit, but what is the problem? At this point of time, we may experience congestion and saturation of transit parts. We may start violating our guarantees about like commit, because attack can be quite long enough in duration, again, and we push all our traffic to caches over transit. It's not a great deal, and again, customers may start complaining because their experience about watching 4K video will be degraded. In many ways, they will not be able to download updates for their games or applications in timely manner. Again, it's kind of degradation, but we are trying to fight against degradation. But what we did is we kind of accomplished it, because this attack, it did not break our network. But what it did, it degraded our service. It's worse than your competitor. It's worse than maybe a different company who actually joins market, starts new business in your area. It may be real impact on your business. How it can be solved? So typically, when companies think about cybersecurity threats, they look for it for perspective of transit. Like, we can buy from a transit provider some kind of DDoS defense. And then it will magically solve all problems. But it will not. Because even if you buy DDoS mitigation from one transit provider, fine. Then you will still need some options to move traffic away from remaining transit provider. Still, you need to do manual job to remove, for example, or depeer your internet exchange points. Because you are actually, in case of DDoS attack, you will need to unplug everything, but keep one transit provider. But again, BGP is not instant protocol. It needs like few minutes at least to move all traffic to your transit provider. In the case of like very large scale of DDoS attacks, it will break your network way before. And also it will cause traffic disruption because of move of traffic from like local caches to remote caches, and lots of changes in your topology. And you don't want to do it. So what is this one is secure configuration, it's common configuration. What is the best one? Best one is case where you have DDoS mitigation, not from, of course from every transit provider, but that's common. You can find this kind of product on market, but also from internet exchange point, just to avoid unplugging it and moving traffic around it all the time. I would not say that this product is widely available, but many internet exchange points actually they started thinking about the direction to offer some, not maybe filtering, not maybe automated mitigation, but maybe some visibility, some understanding, some basic alerts, like something wrong with your prefix, maybe this one. And then it will provide more information for you to avoid unplugging internet exchange points and then thinking about like what we will do next. So, and one of the great things is like it's approach used by DSX, because they actually not only provide nice graphs for you to look at, they also can re-export their telemetry information. It's kind of a secured IPFix protocol to your systems to process it and like prepare reports, prepare some visibility from it. So if you have no equipment which actually can run like NetFlow or IPFix, you can use their like configure it on their portal, and then you can use this information to understand what's going on in your network. Because it's extremely important. Again, consider if you had no experience with DDoS attacks back in time, you have no visibility, and then you can open portal of your internet exchange points and find out like, strange spike of ICMP packets for this prefix. This is very useful information because it will reduce your downtime, it will improve all things, how you can do it, how you can actually stop negative impact from this attack. And so I explained many things which can be done manually, like unplugging internet exchange points, like moving traffic around from one like transit provider to different one. And of course, emergency countermeasure, it's like black hole. Because if we cannot do anything, but we find out what is the target of attack. So I would like to provide more information about product I developed. It's called FastNetMon Community. It offers, we call it DDoS detection application because it can find out like when DDoS happens, what is the target of DDoS. But also sometimes we refer to it as network automation. Why? Because what FastNetMon is actually doing, after detection of attack, it can create a set of special, well-crafted BGP annonces. They may be in scope of host, like /32 or /128, or they can be in scope of minimal routable, like objects, networks, I mean, /24, or it may be like in size of like whole network, which actually consists specific host, which is under attack. And what it can do, it can apply specific communities, and then your routers or your upstream can change routing policies. So instead of doing everything what I explained it, like manually, like unplugging internet exchange points, you can use FastNetMon to detect like, this specific host is under attack, this specific network is under attack. And instead of unplugging cables, which is terrible and will cause degradation of service and for your customers, and will cause great amount of traffic redistribution between your internet exchange points and your transit site, you can move specific /24 away from affected sort. And look what we can do. In case like first way, if we experience DDoS attacks from internet exchange points, we can move it away to transit. Again, if it's still happening and it's happening from transit, okay, let's move it away from like transit without DDoS mitigation enabled, then to transit provider with DDoS mitigation enabled. Okay, if they cannot deal with it, okay, we have emergency option. FastNetMon also can help you to move specific prefix away from your own network and cause traffic diversion outside of your network, maybe to cloud scribing center, like actually like what I referenced about it was backend. In my slides, it was Facility, or you can find any companies available on market. And it will be because they have great amount of experience, they have lots of spare capacity, and they can handle really serious DDoS attacks so against your network. And then, in all cases, FastNetMon can help you. So from perspective of FastNetMon, it works with literally any network telemetry protocol available from your equipment. That's NetFlow, SFlow, IPFix, port mirror for cases if you have actually no telemetry enabled on your switches or your platforms. It works on any Linux box, so it's very simple to deploy. And let me show a few slides about how you actually can deploy FastNetMon in your network, because it's really simple. So, from perspective of integration with your network, it's of course FastNetMon is built around BGP protocol. So because we speak a language which is common for network equipment, and BGP protocol is, quite widely used for public networks. So that's why we use it, and that's why FastNetMon has native support of at least 2 independent BGP daemons. So we use ExaBGP, we use GoBGP. So if you are cannot find out what is the best for you, and if you haven't tried them, just start with GoBGP because it's just great. So, but also we are not limiting project to be BGP automation thing. We also offer ways like how you can call script, and then all kind of magic happens. You can do it, integrate with your automation system, your PagerDuty, or any kind of system existing in place to just notify, we have DDoS, and then we need to apply some actions. So installation of FastNetMon is extremely simple. If you experience it many different projects, I would say. So like installation is not involving compilation of anything. Installation is not involving downloading Docker. We don't need virtual machines. We don't need a bunch of like dependencies from different distributions, manual compilation, lots of like, just call this simple script. And inside of it, because of course it's this script provided for your convenience and you can install it, but what actually happening inside the script is extremely simple again. It does find out what's your Linux distribution and then downloads pre-compiled binary packages for your distribution. So we support Ubuntu, Debian, all kinds of Red Hat-based distributions. So it's extremely simple, extremely fast, and you need just like some time, which actually needed to download something like 55 megabytes of our distribution, and then it will start working almost immediately. FastNetMon detection logic, it's again one of the points where we're trying to be not to be black box. Because it's not machine learning, it's not artificial intelligence, it's not heuristics. FastNetMon built on top of quite simple and straightforward approach of baselines. So, and in case of baselines, you just need to know what's your emergency level in your network. Like if you know that your routers or your upstream will start degrading after like 5 gigabits, that's your threshold. Because after that, there are no points to keep service. You just need to shut it and then deal with it later. It may be black hole, it may be diversion, but it's something which cannot happen on like normal circumstances. So, and FastNetMon just every second calculates bandwidth for and packets per second rate, bytes per second rate, flow per second rate for like utilization for total one, UDP, TCP, ICMP, and then just check them every second against thresholds provided by you. So, quite simple, and then if any threshold is exceeded, it fires actions or causes traffic diversion into maybe cloud or black hole, depends on your case. And so when FastNetMon detects attack, it provides lots of information about what happened, what is the target host, what is the target network, what is the protocol used for DDoS. Like, in addition to information on this slide, it also provides sample of attack. Like something like around 50 packets or flows, depends of, in case of NetFlow-based protocols, which have some information, what kind of traffic was involved in this attack. And then you can make decision, this one looks strange, maybe I can block it, or make like using ACL action, or maybe something different, maybe actually it's legitimate traffic, and in some cases it will need some changes for configuration of FastNetMon itself. So, and one of the nice features in addition to DDoS detection, even if you have no idea, no intentions to use DDoS detection, you can use FastNetMon for network visibility, because internally for DDoS mitigation and detection purposes, FastNetMon maintains counters on basis of prefixes of end hosts and with per protocol utilization. So you can find out like, okay, we have spike for specific, like for which network, then you can open FastNetMon and find out, okay, this specific /24 caused a great spike. And then you move to different diagram to use what is the top talker in this specific prefix? And okay, here you go. And that way you can find out what is like anomaly in your network, why it needs so much traffic. Is it normal, is it not? And so it provides lots of information. Even if you don't want any automation, you can use it for your own purposes in case of attack or during normal operation of your network. So FastNet Mon Community called that way because it's built around community. Since first days of FastNet Mon, it was built according to what community wants from us. Because back in time when I started FastNetMon, it supported just single option to capture traffic. It was port mirror. But at some point of time, quite fast, I got lots of requests. Maybe you can do it with NetFlow? And like, what is NetFlow? Because I came from software engineering background and cloud systems. I had no idea what is NetFlow. Like how many companies, how many equipment run NetFlow? Nice. Then okay, maybe what about IPFix, SFlow? And finally, why you don't support BGP? And we're like, what is BGP? So that's how FastNetMon was built. It was built around real demand of real customers explaining their cases. And you can see we support many ways how you can actually reach us, discuss it with like development team, with different people across the planet running FastNetMon, because we have last time we calculated we have customers of FastNetMon in around 100 countries. Like literally any weird place you can find on map of our planet, you can find at least one customer of FastNetMon in some way. So try it. If you have any problems, reach our community, or you can reach me personally. I will be happy to talk. And thank you for listening.
Oh, okay, we have a question. Okay. Good thing there's a delay on the webcast, otherwise we might, spook them.
We should see. There may be a question, there may be not. What time is ours?
Hi, Sander Stefan. I was looking at your website for FastNetMon, but I can only see like paid commercial options. So what's the licensing idea behind it?
So yeah, that's the reason why we mostly we use website for commercial version, because we also offer in addition to open source, and because we have 2 editions. Like we have FastNet Mon Community, which is open source, completely free, no licensing at all, but it's mostly community driven, and you can find all information about it on GitHub, and like in addition to source code, every information. And on our official site, mostly we maintain information about commercial version, but we have small branching like section of documentation about community version, which has actually all information available for about community version. Actually, you can check this one. It's like because fastnetmon.com/guides, and then you can find all information about community version.
So what's the difference between the community version and the commercial version? Are there things not supported in the community version?
I would say there is a quite small difference actually in terms of core features, because both versions they support BGPs. All versions use exactly the same version of protocol parsers, like for NetFlow, SFlow, like base stuff, because we follow approach called open core, because basic stuff which is like required to operate or maintain DDoS detection, it's open. But mostly like in commercial version, we offer more convenient installation. It's more bundle project. It's not, because FastNet Mon Community is just a piece of your framework. You can select what kind of BGP daemon you want, what kind of metric storage you want, like InfluxDB, ClickHouse, maybe Grafana, maybe Prometheus. But in commercial version, you just download by bundle, like recommended by vendor, and then it magically works out of the box, but it's not providing so much level of flexibility as community version, because...
Thank you.
My pleasure.
Kathy, do we have any questions from the online world? Okay, all right, well, thank you, Pavel.
Thank you for listening.